Welcome to GiViP, our visual profiler for distributed graph processing systems. In this video, we will describe the interface design, the controls that can be used to tune the visualization, and finally, we will show the heartbeat of a distributed algorithm. The interface is divided into 4 views. At the top left corner, we have the aggregation panel. In the top section, we have 3 sliders. These controls have impact both on the trend view and the frame view. The top slider allows us to filter out the working units that are producing the least amount of traffic at the current frame. The temporal aggregation slider is used to group together more than one superstep into a single frame. Finally, we can aggregate also based on hierarchy using the last slider. In the frame view, we depict the traffic load between pairs of computing units. To do so, we implemented an enhanced version of a core diagram. We use concentric circles to encode the hierarchy levels. Circle arcs representing workers or hosts in the same host or rack appear consecutively around the circle. The level depicted in the center of the core diagram is set from the hierarchy aggregation slider. The arcs belonging to the middle section are split into 2 intervals, one for the incoming traffic and one for the outgoing traffic. Edges are represented as ribbons. The size of each ribbon depends on the amount of traffic exchanged by the 2 ends of the ribbon. The buttons at the top of the frame view are used to change page, frame, or start the heartbeat visualization. The cluster view depicts how the cluster is organized. The size of each tile depends on how many vertices have been assigned to the corresponding unit. Hovering with the mouse over each tile will highlight all the corresponding elements both on the frame view and on the trend view. By clicking on them instead, the corresponding elements will be hidden. By clicking on the switch on the top right corner of the cluster view, the latency view is displayed. This view shows the latency between each pair of hosts within a specific frame. We encode this information as a heat map such that each cell conveys the latency between a pair of hosts. By hovering over a cell, the user can read the exact value of latency in milliseconds and the labels of the 2 corresponding hosts, which are also highlighted in the other views. The remaining part of the screen is occupied by the trend view. For each computing unit, which can be a worker, host, or rack, this view shows the evolution throughout the computation of the running time, number of exchanged messages, and number of exchanged bytes. Moreover, to give semantic information on the profiled computation, this view also shows the classes that were executed during the selected frame. By manipulating the commands in the aggregation panel, we can change the visualization to suit our needs. In this example, we set the hierarchy aggregation to the host level. We then set the temporal aggregation to 4 supersteps per frame. Finally, we choose to show only the 5 hosts with the highest traffic, hiding the rest. We close the running time and exchanged bytes trend view, and in this condition, we are gonna show the heartbeat of a distributed shortest path algorithm.